Today our presentation is on volcanic activity in the Caribbean. La Soufriere in St. Vincent I guess would still be considered currently erupting. The experts will speak to that later, I'm sure. And we have decided to have a discussion on it, and also a brief discussion on monitoring and predicting. And I'm sure we will have a great discussion. Our moderator will be Miss Davisha James. Davisha is a geologist from the island of Dominica. She earned her bachelor's in geology from SUNY Geneso in 2017 and master's in earth science from the University of Northern Colorado. To date, her work has focused on volcanology and planetary science, but she is also interested in the overlap between geology and the humanities. She enjoys exploring Dominica's many hiking trails in her spare time. I now turn over to Davisha, who will be our moderator for this discussion.
All right, thank you, and good evening and welcome everybody. Kamala, do you mind doing a quick introduction to CARISTEM as an organization as well? And then I'll carry on.
Fred, quick introduction to CARISTEM.
Yes, I'll do a quick introduction to CARISTEM. Well, did you mean an introduction to CARISTEM or the CARISTEM members who are here? Let me introduce the sorry?
CARISTEM, the organization.
CARISTEM, the organization. So there's a website that I've actually put on there, which is CARISTEM website. We've actually now set up a website where we put like a short bio for each person who's involved, each CARISTEM member. But as I said, in a nutshell, CARISTEM is about sort of promoting STEM in the Caribbean context, to try and sort of, bring the awareness of STEM issues that are relevant to the Caribbean, to Caribbean people. Try to work with schools to be able to sort of, promote STEM subjects or help, promote, get kids interested, to sort of, get them into maybe into STEM careers. We are hoping to, over the next, at least over the next year, over the next few years, to increase the presence of CARISTEM as well. And so events like this, we run them every month, or that's the aspiration at least. So we're seeking to do a lot more networking, to be able to connect with Caribbean professionals as well. I think that kind of sums up what we do in a nutshell, but it's a kind of growing STEM organization.
Okay, great, thank you. So tonight's event is focused on volcanic activity in the Caribbean and the recent eruptions at La Soufriere in St. Vincent and increased activity at Montpellier in Martinique are reminders of the volatility of the region and the risks that we face on a day-to-day basis. So we'll discuss the current methods of monitoring volcanoes and try to speak a little bit about predicting their activity. So we have two guests from the University of the West Indies Seismic Research Center. First, let me introduce Dr. Mikhail Kameho. He's a native of Trinidad and Tobago and has a Bachelor's of Science in Geology with a minor in Environmental Chemistry from the UWI Monell campus. A Master of Science in Geophysical Hazard is from the University College London, which she earned in 2012, and a PhD in Volcanology from UWI St. Augustine. She got that in 2020. So again, congratulations to Dr. Kameho. Her expertise is in igneous petrology, petrography, and volcanology, and she has done extensive studies of volcanoes in the Lesser Antilles, specifically Kikamjeni, the submarine volcano off the coast of Grenada. So we're also joined by Dr. Elias Papadopoulos. He is an engineering seismologist with a PhD in geophysics and engineering seismology. He is currently a research fellow at the UWI Seismic Research Center, having arrived via the Hellenic Mediterranean University in Greece, where he lectured for over 11 years in the Department of Natural Resources and Environment. He is actively involved in the UESRC monitoring and seismic and volcano monitoring network. And because of that, he's uniquely qualified to speak to us tonight on the effectiveness and challenges of the monitoring systems in the Caribbean. So thank you to both of you for joining us this evening. And I understand that you have a presentation to share with us.
Yes, we do. So I'll just share my screen and I'll start. Okay, I have to be allowed to share from the host.
How do I?
You just have to enable other people.
Yes. Okay. Sharing. Right. Okay. Multiple. Let's see.
Okay, great.
Does that work?
It works. Yeah. Can you see my screen?
Yeah. Yeah.
Okay. So I will start with this presentation. So good evening again, everyone. My name is Mikhail and I'm a volcanologist at the Seismic Research Center. I'm currently responsible for monitoring ground deformation in the English-speaking islands of the Eastern Caribbean. So today, Elias and I will talk to you about volcanology in the Caribbean, and hopefully this will stimulate further discussion about recent activity in the region. So the first question we would ask is why we have volcanoes in the Caribbean, and that's a direct result of our tectonic setting. So we live along a plate boundary in the Eastern Caribbean where two plates collide, and those are the North American and Caribbean plates. And as these two plates collide, because the North American plate is heavier or more dense, it subducts or sinks below the Caribbean plate. And this process is called subduction. And as it sinks into the different layers of the crust and into the mantle, the higher temperatures and pressures cause the plate to melt. And then this molten rock is less dense than the surrounding rock. So it then rises through different layers of the crust again and erupts as volcanoes. So all the islands in the Eastern Caribbean, from Grenada in the south, straight up to Saba in the north, formed as a result of this volcanic activity happening over millions of years, resulting in the formation of these islands. Now, all of these islands have at least one live or potentially active volcano, and Dominica is unique in having 9, so the volcanic risk is increased in this island. And subduction rates are generally low, so it's about 2 centimeters per year, and this has resulted in relatively low magma production rates and resultingly low magmatic activity. And we can see these variations in the arc. So the arc is the span of islands from Saba to Grenada, and we see variations here with the size of the island. So if you see in the central part of the arc, Guadeloupe to St. Lucia have bigger size islands to the north and the south, just reflecting variations in magma production rates. So some considerations we have to have when we are talking about volcano forecasting. And I talk about forecasting here because most people think that we predict volcanic activity, and we don't use that term because it suggests that we can pinpoint a specific day or time when an eruption can happen, which we can't do. We tend to forecast them. So some considerations are that volcanoes in this region don't erupt very often. So if you look at this, I've put some historical eruptions from about the 18th century to present. And the first thing that we see is that not all of these volcanoes have erupted in historical times. So I've said that they are all considered to be live, but not all of them have erupted. So this means that not everyone has a living memory of a volcanic eruption. So this has considerations for perceptions of volcanic risk. And for those that have erupted, most of them haven't erupted very often. So we see that Montserrat has only had one historical eruption, and that would be the eruption that we've had from 1995 to present. And the most active or most frequently active volcano is the Kikamjani submarine volcano, which has had 14 historical eruptions. So we can see, okay, well, let's go back. Are you hearing me? Sorry, okay. We can see, let's go back beyond historical time into the geological record to see if we can get a better idea, a better understanding of how these volcanoes erupt. But we have problems there as well. So we tend to have an erosion of deposits and a lack of fieldwork and dating in all these different islands to give us an adequate idea of what the volcanic activity would have been like in the past. And these volcanoes tend to have 2 types of activity: effusive or dome-forming eruptions or explosive eruptions. And generally, domes that are recorded in the geological record aren't always recorded. So for example, you might have a dome forming, like in the recent eruption in St. Vincent, which we will explain later on. And then the dome is later blown off by a subsequent explosive eruption. So we tend to underestimate the frequency of prehistorical eruptions. So generally, the eruptive record is short and biased, and this can affect our ability to adequately forecast eruptive activity. So we at the Seismic Research Center monitor volcanoes to try and anticipate a volcanic eruption. And this is possible because as magma works its way to the surface, different monitoring signals can be detected, because as magma goes to the surface, the ground may swell, and this is manifested in ground deformation. Again, as magma rises to the surface, you may have cracking in the different layers of rock within the edifice, which is manifested in seismicity or volcanic earthquakes. And of course, this increased permeability results in edifice cracking, which results in different volcanic gases making their way to the surface, which can be measured using different geochemical monitoring techniques. And usually before a volcanic eruption, it's followed by precursors, but this isn't always the case. So at SRC, which is based in Trinidad, so we in Trinidad, which is the headquarters of SRC, we monitor all the volcanic islands in the English-speaking Eastern Caribbean. So that does not include the French islands, Martinique and Guadeloupe, or the Dutch islands, St. Eustatius and Saba. And we use about 4 monitoring techniques. We use GPS to monitor ground deformation. That's the main way we monitor ground deformation. We have a network of ground-based instruments, which includes GPS instruments, as well as seismometers throughout the different islands, which are used to monitor volcanic earthquakes. And then these ground-based instruments are supplemented by periodic visits to these islands to do geochemical monitoring of the volcanic gases and waters in the hydrothermal systems. Recently, with the advent of satellite monitoring, satellite monitoring, we have new techniques to use to monitor volcanoes. So we can use satellites to again help to monitor ground deformation, and we use a process called INSA. And also we can use the satellite imagery to give us an idea of how volcanic eruptions evolve over time. So we can map thermal anomalies using satellites. We can monitor how volcanic gases or plumes during explosive eruptions are tracked, how the trajectories are tracked and their gas contents using satellites. So with the advent of technology, we have different ways that we can use to monitor eruptions before they happen and when they happen. And we've been doing this since 1952, so 60 years, more than 60 years. So I'll now go on to speak about the recent eruption at La Soufrière in St. Vincent. And this is a picture that I would have taken when I visited there in February. This is a picture of the volcanic edifice around that time. And you can see a kind of brown discoloration along the edifice where the volcanic gases from the growing dome would have destroyed some of the vegetation there. So before the eruption started, this is on the top left-hand image is a picture of what the crater of the volcano would have looked like before. So we had the presence of a dome, and this was the result of an eruption that happened in 1979. And we also had a crater lake, a small crater lake present at the time. And before the eruption started in December, there was some elevated seismicity about 2 months before, but this was not unusual because volcanoes tend to have periods of unrest at different periods of time. One of our scientists was actively monitoring satellite imagery and was able to detect from the NASA firm's website a thermal anomaly on the 27th of December, suggesting that you had some sort of activity happening. And then the local Soufrière monitoring unit, upon our instructions, visited this edifice of the volcano, the crater, and noticed that a dome was forming. So in response to the effusive eruption, this dome forming effusive eruption, which is what we call a calm eruption, we deployed scientists from Trinidad to go to St. Vincent to densify the monitoring network. So I have to say, before the eruption started, our monitoring network was a bit decreased due to the COVID-19 pandemic, which restricted our movements to maintain these stations. But in response to the eruption, we were able to get exemptions, travel exemptions to go there and densify the network. So we install a number of continuous GPS, which means permanently operating GPS stations and seismometers to help monitor the volcano. And these are some pictures here of our different activities. We also install a camera to help, so we can have a visual view of the volcano at all times. And we also did, we supplemented the continuous GPS network with campaign GPS, which means we just did small occupations of GPS on the volcano. This is a picture on the bottom right-hand side here of us doing that. And then some of the scientists also measure some of the gases emanating from the dome, all in an attempt to gather information to continue monitoring the volcano, because this volcano has had a history of having two types of eruptions. It can form domes, or it can be explosive. Sometimes both of those types of eruptions happen in the same eruptive period, or sometimes they just happen in isolated ways. For example, in 1971, it formed a dome and then ended. But in 1979, the eruption started explosively and then ended with a dome. So this volcano tends to do different things depending on the configuration of the system. And this is, again, the importance of getting an idea of the historical and prehistoric activity to try and help figure out how a volcano is likely to behave. We also try to track the growth of the dome. So it started off growing in a conical way, and eventually, as the dome got bigger and bigger, it kind of started to form lobes, and the growth of the dome was restricted to the presence of the old 1979 dome. And we used two techniques to try and measure dome growth, because we try to use drone surveys. So
Harvey, what you doing?
we try to do
Why?
up to the
Harvey, take the
someone's mic is not muted.
the hanger down.
Guys, please make sure you're muted.
Right, so we did weekly trips to the volcano summit to try and monitor the activity of the volcano, and we used drones to try and map the growth of the dome using photogrammetry. However, hiking up to the volcano is not very easy. It takes depending on which side you hike from, it takes 4 hours on one side or 2 hours on the other side. And then when you get to the top of the edifice, of the crater, sometimes the atmospheric conditions are not conducive to flying a drone. So if you have a lot of cloud cover, the drone can't be flown. So we supplemented this by using satellite imagery, and all of this was used to monitor the dome growth. So now I'll give way to my colleague, Elias, who will talk about volcano seismology.
All right, thank you, Mikhail. Shall we continue using your screen?
Yes.
All right. So the major method that we are using as a continuous method to monitor the activity of a volcano, which can have immediate effect on what we are doing, is the seismic monitoring. So as Mikhail showed you in a previous image, we expanded the network at the beginning of January from 2 stations to 8. And the logic was to have some stations close enough to the summit so we are able to detect even the smallest of activity that happens, but also have some stations at further distances, because if things start going south, then the stations that are very close, they might get destroyed from the activity. So what you are seeing on this graph, on top, you are seeing from the 8th of April till the 19th of April, what is called RSAM. RSAM is a measure of the amplitude of the ground motion. It is being averaged either by a minute or by 10 minutes. So what you are seeing, the peaks that you are seeing, the spikes that you are seeing are denoting intense activity. So until the 9th of April, on the top left, the blue line denotes a station that it is very close to the summit. It was like about 200 meters from the summit, which was having an increasing activity. That's why you see the spikes are getting higher and higher. Then at some point it stopped, and this is the point where we had the first explosion. So we are assuming, because we haven't visited yet the place, that the station is just destroyed. And then after that, you see with the black line, a further station, a further away station, which continued working during the whole time, and it's still active. So with the red dots at the bottom, you see the explosions. So we have counted 33 distinct explosions from the summit at La Soufrière. And from there, we can monitor the activity, because at the time when the activity reaches its peak, where you're starting heavy explosions, the conventional seismic monitoring is useless. You don't have distinct signals. You have one continuous tremor that goes on, can go on for hours or for days. So your best advice is to use some secondary techniques, or to have visual, which in our case was again not very easy, as there's no planes or helicopters flying around, and the ash was so big that practically the whole island was a dust ball, so you couldn't see anything. So this is one way how we are monitoring the ongoing activity, and we can decide what it is. And obviously, based on this, we can advise the relevant agencies of how to proceed to protect the population. On the middle and the lower screen, you are seeing events. These are all seismic events. These are all distinct seismic events. These are distinct earthquakes that are happening, but they have been classified as to what kind of earthquakes they are. So when you are having volcanoes and volcanic activity, we have a classification of 4 different types of earthquakes, which are related to different phases and stages of the process that it is ongoing. When you are having processes that are happening at depth, at relevant depth, which implies that the magma is trying to move and come up to the surface, so it is pushing the rock formation that is overlying it, you are having what we are calling a volcanic tremor, which is a high frequency signal that is produced as the solid cold rock is being cracked by the pressure of the hot magma going up. Then we have another type of earthquakes, which is called the long period earthquakes, which are associated with the presence of fluid. Either that might be water and gas, water alone, gas in high density, which it is in high pressure and high temperature, and this is also creating a push to the formation, and that produces a different type of signal. Now, the significance of this is that as you are reaching closer to have an explosion or an eruption of a violent type, you see that the number of volcanic tremors, or VTs, is increasing. So as you are seeing in the middle figure, you see that we have activity that is reaching its top on the 9th of April. This is the magma coming up. After that, the magma is up, so we stop having this type of activity, and we are starting having the LP, the long period earthquakes, which is now you have an open vent where the gas and the water in high pressure and high temperature is coming from underground. And as you can see, until the 19th, we have, every time that we have an explosion, these type of explosions are caused by the gas and the water coming at the surface. Next, please, Mikhail. In terms of waveform, so what I showed you before is events, so classification of events and counting of events. This is 2 stations that the example starts at the 7th and ends up on the 9th, so ends up when we had the first explosion. So as you can see, this volcano, La Soufrière, before it reached the point that it cracked open, it didn't have that much of activity. And this is one of the characteristics of this volcano. And that was also recorded in the previous eruptions, both in 1979 and in the older ones. So what we are seeing is that there is not that much of activity until the system reaches the critical point on the 9th, where it cannot handle anymore being in this pressurized phase, and then it cracks and you start having explosions one after the other. So as you can see on the 9th, the 10th and the 11th, which is the three last lines per figure, we have constant explosions that are happening. As soon as the system is sealed and the pressure is building up, the pressure builds up so fast that it creates another explosion, and then it cycles back and forth through all that until it reaches the 19th, where we believe that the system lost the majority of the pressure that was under it, so it ended in a kind of a hibernating state, where now it's just venting without creating this violent type of reactions. Next, please. Another way of understanding what we are seeing at the drums, so to explain and interpret the previous figure that I showed you, actually all the previous figures, is calculating what is called the seismic spectral amplitude measurement. So this is the S sum in comparison with the R sum that is measuring the average of the amplitude. So here we just convert the time waveforms into the frequency domain, and we analyze the frequency that the energy is concentrated. So if you have energy that it is between 1 and 5 or 8 hertz, then you know that this is something geological. If you have some atmospheric disturbance, there is some thunderstorm, or there's rain, there's wind, then you will get signal concentrated in other frequencies. This way you can understand if what you are seeing comes from the volcano or if it comes from some other source that is disturbing your network. So as you can see, these are taken, these snapshots are both on the 9th of April. So the first explosion has already happened. And this is at a duration of 10 minutes from left to right. And you can see that within these 10 minutes, you have a constant depressurizing of the system. So the system, as the pressure is coming from the bottom, it is so high that it constantly puffs. So it releases one puff, and then after a few seconds, it releases a second puff. So this kept on going in St. Vincent for, in the first phase, it kept going for 3 days. Then it calmed down, and then it changed its pattern and started doing it every 2 hours. We had some seismic activity, which resulted in every 3 days to have an explosion. This is part of the monitoring routine that we try to understand what the volcano wants to do. How is it thinking? What is the next thing it's going to do? Are we still in an eruptive phase where it's going to continue doing this and more explosions and more ash going on and more possibly pyroclastic flows? Or we are seeing a decrease in that, the time span is increasing, so less and less frequently these explosions are happening. So we are going into a phase where things are going to go down a little bit to normal. Next, please. I think that Mikhail put this map here to show you what was anticipated and what happened in practice. So St. Vincent was lucky that just before the activity started, UESRC finished a project which was called the Volcano Ready Community Project in St. Vincent, where we work with the communities and trying to bring awareness to the potential danger. So they can understand, based on where they are living, what is the level of risk that they are facing because of the loss of air. So the result of that was the map that you see on the left, which is being classified in a cup style system. So it has red, orange, yellow, and green, meaning a higher risk towards lower risk. And this map was produced mostly taking into account the projectiles. So this map reflects what we expect to happen in terms of things, projectiles coming out of the crater, and they might fall in a certain vicinity. So the red zone was the zone that was designated as, in case we need to evacuate, these guys need to go out of there. We don't want to have a single person in this zone. The orange zone is at a less risk, but still at risk. So they left this as optional. People who wanted to evacuate, there will be shelters at the green zone that they will host them and whatnot. And then the yellow and the green was people, the yellow was people who were on alert, and the green was people who considered that they will be safe. So this was used as a guidance for us and for NEMO to plan, for NEMO essentially, to plan how they are going to act and how to operate with the communities during this whole time. And it worked for the biggest part, it worked exactly as the hazard was produced. So the orange zone got some impact, but it was nothing compared to what happened to the red zone. So the map was precise, and we are glad that we have something like that as an example, that we can do that in all the other volcanic islands to help them be able to prepare better for the future eruption that will happen at some point during their lifetime. Next, please. All right, this is a video, it's a satellite video that shows the ash. So the ash that you see from the center, because of the higher winds that blowing to the east, you see all those puffs. These are the distinct explosions that are happening, and how the wind is carrying all this ash to Barbados and then further to Africa and as far as it went. At some point, we got some reports that the ash actually traveled all around the world and returned to St. Vincent from the west. So it was a lot of ash. It was we weren't expecting it to be so ashy. We knew that it's going to be ash because that's the type of volcanoes we have in the Caribbean, but we didn't expect that the volume of the ash will be that large and that it will create that much problems both to St. Vincent and Dominica for the most part, and then to the other neighboring islands, Grenada and St. Lucia, but at a much less extent. Next, please. All right, and this is so as scientists working on volcanoes, we work before the eruption, trying to monitor as best as we can, so we can understand how it is and advise the relevant authorities. We work during the eruption, so we can understand how it acts and trying to understand the immediate behavior of it, but we also work after everything is done, because we need to monitor the impact of the volcanic activity. So in the pictures, you see different types of impact. So on the top left one, you see everything is covered in ash. The whole place looks like it's snowing, looks like it's Christmas. This ash is heavy, and the biggest problem is that due to, especially if it gets wet, it gets even heavier, and then it might pose a risk to the roofs. So you might have collapses of roof, like you see at the bottom left. At the bottom center, you see, this is Dr. Thomas Christopher from MVO, who visited, I believe it was around the 13th or 14th of April. So we are still in between the explosions. He visited the Larakai River, and what you see is a pyroclastic flow and a lahar on top of it. So you see the destruction that happened. You can see at the background that everything is covered with ash. The trees in front of him have been burned, have been ripped off from the flanks of the volcano. They have been transferred all the way down to the sea. At the top right, you can see a pyroclastic flow. I don't know if it is easy for you to understand it, but at the top of the picture, there is people sitting. There is two people at the center almost of the picture to the right. There's two tiny colored things, which are people, and what you are seeing under them is the deposits that came down from the mountain because of the pyroclastic flow. So you have deposit after deposit after deposit of hot debris, gas, magma, water all rushing down and burning everything on their way. And then you can see how the whole volcano, the whole mountain actually got burnt out due to the volcanic activity. This will have some benefits in the future, but at the moment, obviously, it is a destruction of property, of crops, livelihood. Animals most likely have died there. And then the animals that have been left stray from the owners have to find something to eat, and everything is covered in ash. And this is it's a big disaster. Next, please. I think this is Dr. Kameho's expertise, so I'll let you continue.
Okay, thanks, Elias. So I put these satellite imageries here just to show you the importance that satellites proved during the eruption. So the top left-hand side shows you how the crater was configured before the explosions. So you can see the 2021 dome growing next to the 1979 dome. And then once the explosion started on the 9th of April, those domes were essentially just blown off, leaving a big hole in a new crater, which we call the 2021 crater. And satellite imagery was very important because we couldn't actually, because of all the pyroclastic flows and the ash clouds, we couldn't have a good visual observation of the crater. And also we lost the cameras at the summit. And we need to have an idea of what was going on at the summit to help us with our monitoring and with the advice that we would give to the local authorities. So these images were provided by international agencies who helped us in the response. So we can see the progression of the configuration of the crater over time. So on the 10th of April, we had an open crater where we had all this ash venting happening with subsequent explosions. And then this bottom right shows you 19th of April coming towards the end of the explosion, which ended on 22nd. So we have some infilling now of this crater. So you have explosions and then material infilling, which we see on the bottom right-hand side here. And then the top right-hand side shows you after the explosions, what the crater looked like, showing you again the infilling of this crater material. So satellites were very important in terms of our monitoring during the eruption. And I'll just leave you this final figure of what the crater currently looks like. So we no longer have a significant dome. We just have a kind of open vent with gases coming out. And we continue to monitor using all of our ground-based instruments. Currently, we have a team on island who are putting in new instruments that would have been lost during the initial explosions. But yeah, this photo was taken by a helicopter agency that was able to give us an idea of how the volcano is looking at this current time. And yeah, we will continue to monitor and provide updates to the local authorities. So I'd like to end here. And thank you for listening. Stop share. Davisha, I think
I was muted. Yeah. All right. Thank you. Thank you for that very informative presentation. There was a lot in there. So let's see how much we can go through in the time that we have left. So I'm trying to put some of what you talked about into context for people who may not have a whole lot of experience thinking about this sort of work. Let's start with the monitoring stations that you lost. So you mentioned that first of all, in St. Vincent, the network wasn't ideal due to COVID, and that you lost a seismic station and a camera during the eruption. So for people who may be wondering why their island isn't just covered in stations from head to toe, why their network isn't as strong as they would like it to be for them to feel secure, can you talk about the cost, like the financial cost and the manpower required to keep a network going?
Yeah, sure. The reason is purely logistics. For example, first of all, seismic works in two ways. One way is to monitor earthquakes that happen in the Eastern Caribbean. So we need to have a not so dense network of stations to monitor the earthquakes. And then per volcano, you need to have a very dense network monitoring the volcano. And as I said, the stations have to be close to the summit so you can see the microactivity, and then further away from the summit so you can have the general picture. It is too costly. And let's face it, in the Caribbean, we can't afford it. So you need, let's say, for St. Vincent, you will need to spend about $300,000 to $400,000 US to properly monitor it. That is the first problem that we have. The second part is that because our stations have to be in remote areas, you can't put them in the middle of Kingstown. You have to put them somewhere where there's no people. That means that because there's no people, most likely there is no way to bring the signal online to your headquarters. So you have to have a way, and we are using radio frequencies, we are using repeaters, we are using a lot of different technologies to be able to bring the signal. But that makes it very complex, which makes it easy to break. And then once it breaks, it means that someone from Trinidad has to get on the plane, go to St. Vincent and fix it. Now, if this happens every week, obviously you can't go every week and fix it. So as much as we want, and we usually pre-COVID times, we're planning at least to have one trip a year, usually before the hurricane or after the hurricane season, depending on which island it is, to make sure that whatever got destroyed, we're going to refurbish it and put it back to use. It is not always possible. It is really a problem to maintain the network that we have when you have so many islands, so many volcanoes, remote for one from another. So to go from here to Sabah, we need to plan it 2 years before. So imagine if something urgently happens to Sabah, we have to rush and get there. Our presence in St. Vincent started on the New Year's Eve. So we immediately deployed people and instruments to get there, but we had to do it as fast as possible because it was an emergency. And we were lucky that we actually had instruments in our pool and say, okay, let's take everything we have and put it in St. Vincent. Because if we didn't, we would have to order, and ordering instruments takes months to complete and have them back, calibrate them and put them there. So it is a complex business how to maintain it. I wish we could say that, you know what, all the islands are perfectly monitored and we are sitting comfortably at our houses in Trinidad and just watching the monitors and understanding what's going on, but that is not the reality.
Yes, absolutely. And that actually ties into a question that someone from the audience had, as you mentioned, sitting in your houses in Trinidad and looking at what's coming in. They would like to know how you monitor remotely, because you're not in every island at every moment. You have the stations. So how do you get the data from those stations?
Well, effectively, everything we do is remote. I mean, the term remotely means that you are not there. And when we're talking about the volcano, even the volcano, we monitored it remotely because we weren't inside the crater, or we didn't have instruments inside the crater. There's two main things that we're doing: the ground observation and the satellite observation. I will give you a very brief about the ground. So what we are using is the seismic network, which is 24/7 operational and monitors every second the activity. So something goes up, and then we can have it. Everything is streamed in real time through internet to our headquarters. So at any point of the day, we can have an idea of what's going on. The same goes for the GPS ground stations that we are using. And if available, and if we have the time at some point, or for some reason we are on one of those islands, we also try to perform some geophysical measurements, which are going to give us, at the time that they are being done, some of the geological conditions of the ground, which will be used as an extra information to understand what's going on. And also they are used as to the processing that we are doing to process either the GPS or the seismological data. The satellite monitoring is I find it fascinating because anyone from anywhere around the world can use it. So we had people from England, we have people from Paris, we have people from, I believe, Italy. Mikhail is the expert, and I want you to give the input. Who they weren't here, they weren't part of UE. They were just in their office, but because they have access to the satellite passing over the Caribbean, they said, okay, you know what, we process the data, here is the image. But Mikhail can give you in detail this aspect.
Yes, thanks, Elias. So a lot of satellite data is not open source, which is, so we won't be able to access it because we don't have subscriptions to them. Some of it are open source, but those don't give you high enough resolution. So once the eruption started, in response to the crisis, the international agency really came to our aid and offered their services for free. So they gave us all this access to satellite imagery where we were able to see what I showed you in the presentation. But in terms of ongoing monitoring, that is not something that we use all the time in terms of looking at how the volcano looks configuration-wise. But we can use satellite imagery, satellite data to measure ground deformation. So we do something called INSA, and there are open source imagery that we can use to do that. But another type of satellite data is GPS. GPS uses satellites to monitor ground deformation as well. So we use satellite data where possible, and that works for the most part. And when we have crises, when international agencies respond, that really helps.
Let me add
Can we
here.
ask?
Allow me please to finish just for, since the topic is what technologies are being used and what not. So satellite imaging is something that it is relatively new. It happens in the past 15, 20 years, and it's constantly being improving. There is one small problem that we have with that, some of the sensors that are on the satellite might have a problem passing through the cloud. So if the place is covered with clouds, then it's blind, they can't see. Or if they're trying to make visual, like make an actual picture from space. And some others using different sensors that can penetrate through the cloud and actually reach the surface. But the biggest problem we have right now with the satellite monitoring is that the satellites are not static. They are not sitting on top of St. Vincent providing images every minute or every second. They are passing, so they are going around the globe. So they are passing every, maybe a day, every 2 days, it might be every 2 weeks, depending on what satellite is and who operates it and what kind of sensors it has on it and whatnot. I would expect that in the future, and as we have more satellites up there, we already have enough, but there is a lot of plans to have even more satellites. And if at some point there is a geostatic satellite that is actually sitting on top of St. Vincent or Dominica, then we will be able to use it as a continuous monitoring feature, because it is very important to be able to have a continuous flow of data. Because that's when you understand when things are changing. At the moment they are changing, so you can make informed decisions what to do next. And this is the part where the seismic network is irreplaceable, because it is 24/7, it operates at all time, at all weather, as long as there's no problems. So this is the primary tool that we're using in monitoring the volcanoes. The satellite is complementary, and at some point when we got blinded by the ash and by the conditions on the ground, because some stations, it wasn't just the stations that got destroyed. The northern part, the red zone, the government cut off the power and the communications to prevent people from going there, which means that we lost our data. So our network started with 8 stations, and at some point it gave down to 3. And it was the 3 at the south of the island, which were like receiving the less information from the volcano. So at that point, our best information was the guys who were sitting actually at Belmont, and they could see the volcano, the summit right in front of them, if the wind blew some of the ash, and they were able to tell what is going on. So nothing is perfect. At that point, though, satellite images were actually very useful, because Mikhail was processing them. She was in close contact with the the other people, and they were able to guide us and say, okay, you know what, based on the satellite image, even if it is 2 days later, now we know what's going on.
Can we ask a question or?
Yeah, sure. I was going to change the topic slightly. So yes, if your question is related, go ahead.
Yeah, it's related to this. And basically, so recognizing that we do have the constraints of technology, the cost and so on, to have the monitoring and so forth. We also know that, okay, we have Martinique with Mount Pelée, which is right next door, which also had some activity earlier, I think was last year as well, and so forth. But do we collaborate with maybe the authorities and on the French or the Dutch to perhaps leverage their satellites, their technologies to in our monitoring? Because we all geographically in the same area.
Yeah, this is exactly what happened during the explosive
Okay.
phase. So some of the agencies, let's say international, because Guadeloupe and Martinique are French. So
Yeah.
France would have lent their assistance as with satellite imagery as well. And then beyond that, beyond the ongoing activity, we get GPS data from the French islands and the Dutch, well, not the Dutch right now, but usually we get GPS data from other islands and countries in the region to help with our ongoing monitoring. Because we don't just focus on volcanic activity. We are very concerned with tectonics and earthquake activity as well. So we, in terms of GPS, we get data from other territories as well. And I'm sure Elias, the same is for the seismic stations in Venezuela and so on.
Thank you.
Yeah, the collaboration is, it didn't start with the La Soufrière activity. We have memorandums of understanding and agreement with all the neighboring countries. So the seismic networks between us, the French, also the USGS, which has some stations in the area, they are all being shared among everyone in real time. We are also getting data from Venezuela. During this phase, the Guadeloupe Met Office gave us access to the radar, so we would monitor the cloud activity. So we were part, let's say, of their team, so we had access to their radar to see if it's going to rain, how is the wind blowing. When we needed helicopter support, the French sent a helicopter from Martinique and Guadeloupe to St. Vincent to carry the team up to the summit. So we do have a collaboration. We had it before, just at this time it was intensified because we needed them, you know, in a more urgent way. But there is a collaboration and it goes both ways. We help them and they help us. If they have some problem, like let's say if tomorrow Mount Pelée, which Mount Pelée has been active for the past 3 years, it's still going in unrest. People always link it to La Soufrière, which there is no linkage. It's totally independent, so it's acting on its own. It is not at any way affected by what happens to St. Vincent or any other island. But let's assume that tomorrow Mount Pelée starts acting funny and the French say, you know what, we need a team of you guys, then we will go to help them.
Thank you.
All right. So
Hello, I have a couple questions.
Oh, okay, 1 second. Can you put the questions in the chat, please?
I did.
Okay. I will. Again, I'm trying to get to as many as I can before we wrap up for the evening. Mikhail, you mentioned that you aren't really fond of the word prediction because that implies saying at a specific time on a specific day, X is going to happen. And forecasting is a better way to describe that. But can you clear up how specific or general you can get with forecasts? Because right now, for example, there's a question in the chat about getting 3 or 5 days notice, and that is a lot of time. So I think sometimes people tend to think of it like hurricane forecasting, when you can give a lot of notice because you can see something coming and give an idea of the strength and where it's going to go. So could you, or Elias, speak to that a little, please?
Yeah, thanks, Avisha. So it really depends on the monitoring data that we have. So luckily when the eruption started, it was effusive. So we were able to identify a network. So we got some level of baseline data that will help assist with the forecasting, as it were. And this is really essential in trying to use this background activity or elevated activity to figure out what types of activity are likely to happen afterwards. And for this event, seismicity was really the key factor for us in forecasting the eruption. So all the other monitoring signals, I speak specifically for GPS, didn't really show much variations in activity, but seismicity was the key contributor. And in this case, we were able to give, I guess we'll talk more about the exact seismic signals, but in this case, we were able to give the local authorities 24 hours notice to evacuate the red and orange zones, which is a lot of time. 3 to 5 days is a stretch, but 24 hours was adequate, and it did work. It resulted in no deaths at all, which is a nice success story for this eruption. But generally, to give adequate forecast, you need to have a long baseline of activity, of monitoring data to help with your forecasting. But usually short-term to medium-term forecasts tend to be with days and weeks. We can say, like, for example, La Soufrière's historical activity, we can say, okay, it has had 7 historical eruptions. So we can say you have a repose period of about 30 to 40 years. And lately I've seen that this period has been shortening. So we can say, okay, in the next 30 to 40 years, we can expect another eruption. So that's a long-term forecast. But in terms of shorter-term forecast, you really need that monitoring data to be able to inform any advice to local authorities.
Yeah,
And on that note, somebody else would like to know, at what point do you alert the authorities? So I know it's not that you're just sitting on a hoard of information and when something big happens, you send a call out. So could you let folks know how often you update government officials and hazard planning groups on the islands, please?
We don't report to the respective governments in a routine way, like every week send a report that says, okay, everything is well or something is happening. If something is happening though, we send out a report that describes what we feel happens and what we expect that is going to happen in the near future. And then we just pay more attention to that specific island. With regards to the previous question and to this one, me personally, I avoid to use both words, both prediction and forecasting, because it is very difficult. And people, when they hear them, they have something very specific in mind. So even when the team was on the island and they could tell that things are intensifying and we are going to an explosion, it is still not easy to pick up the phone and say it's going to blow in 24 hours. And you have to understand also the logistics behind it, because then you ask the government if they accept your advice to mobilize a lot of population to disrupt their life and then load them to some other place where they have to take care of them, they have to feed them, they have to give them shelter. It is not an easy decision either for us to advise and also for the agency to take. So in this case, there was a daily briefing of the Prime Minister and the Director of NEMO by the team leader, once a day at least, that was saying, okay, since yesterday, this and this has been observed. And then as things started progressing, this increased into twice a day, and then it came to the point that wherever needed, pick up the phone and call. I think that I can use the word we were lucky enough, but I would prefer to say, and also to bless ourselves, that the team that was on the island at that specific time was experienced enough to say, okay, this is the time where we have to make the call and tell them that they need to evacuate. they could have got it wrong. Imagine that, I mean, the volcanoes and the earth is unpredictable. It doesn't mean that it could go down. You can say, okay, evacuate, and then nothing happens for 5 days. Then people get anxious, like, why did you take us off our homes and nothing is going on? People go back in, then suddenly activity changes, thing blows out, and people get dead. It is not, it is a very fine tuning between what you are seeing, your experience, and to have a feeling that this is the moment that I have to make the call and tell them, okay, get out of there.
Yeah, it's definitely not a cut and dry or very simple decision to make or announcement to make. So thank you for clarifying that. So we are at the hour now, and this is the time the event is supposed to wrap up. So can the host say that if we're extending because there are still questions, or?
If people are happy to extend the discussion to another 15 minutes or whatever, and if our guest speakers in particular are happy to, then I have no objection to this. But I would put a question to our guest speakers and whether they need to leave or if they're willing to extend the discussion for a little bit longer.
I have no problem to extend it if Mikhail.
Yeah, I have no problem.
All right.
Davisha, should we agree extension by what, 15 minutes or 20 minutes if people agree? Yeah.
Let's do, I think 20 minutes would be good to wrap up, I think.
Okay, thank you.
Okay.
I would like to ask a question.
All right.
Can I proceed?
Yes, you can go ahead.
Yes, I wanted to understand a little bit more about the monitoring of volcanoes, La Soufrière in particular, but the other volcanoes in the region. I understand the financial constraints, and I imagine there are also some human resource constraints given the specialized nature of the skills. So I wanted to know what other sorts of approaches are possible, whether the use of larger numbers of less sensitive or less precise instruments, or whatever other means there are that might be worth exploring given the economic realities of the region. I also wanted to know of the extent to which something like a UAV or a swarm of UAVs might compensate for the limitations and difficulties of the use of satellites. And finally, whether there was any particular part of the EM spectrum that would sufficiently penetrate ash clouds so that you could be collecting useful images and useful information in the presence of ash and steam. Those are the immediate questions that came to me.
All right. I think the last one, Mikhail, is more appropriate to answer, but I'll give you the answer to the first one. We did use drone during the La Soufrière eruption because we wanted to have some images in between the satellite availability. But even the drone, if you are in the situation where you actually have the ash cloud in the air, you can't fly a drone because you don't know where you're flying it to. And you don't want to jeopardize sending the drone above the crater, and then it blows out and you lose your drone too. Plus, you have to be close enough. I can't be sitting in Kingstown and send a drone to the summit, which is 12 kilometers away. So the risk is too high. But before the eruption and after the eruption, so when the conditions were better, then yes, we did use the drone. But the problem with the volcanoes is that the drone and the satellite comes useful once you have things on the surface. And that is already too late for you because we need to know that the activity has started. We knew that something was happening in St. Vincent since October. From the beginning of October, we were starting getting more frequent volcanic events. From 0 to 1 a day, it started to be happening 3 a day. then it became 5 a day, then it kind of stopped, then kind of picked up, but we knew that something is brewing. So that is the benefit of having the seismic monitoring, because you are seeing things that you have, which are underground, and you have no other way of seeing them. One good way, another good way of knowing things start happening from the beginning is to have a permanent, continuous geochemical analysis system. So to monitor the gas. As the activity starts getting heat up, then you have a difference in the chemical analysis that might help you to see that, okay, something has changed. We see more content of CO2 or SO2 in the water or in the air, so that might mean something. But our eyes essentially are the seismic network, because you can tell from the very beginning, as long as there is precursors, then you can actually get them using the seismic monitoring. The drone, the UAV, the satellite, the airplane, whatever else you want to put in the air or come from the air is useful once things are already in the surface. That is the thing. But until then, our only way to do that is using the seismic and to, if possible, to have a monitoring of the gas emission or the temperature of the water or something like that. Mikhail can answer the last part about the frequencies and if they can penetrate the ash.
Yeah, before I do that, just to follow on from your comment, Elias, in terms of GPS monitoring, each GPS instrument costs about, a GPS receiver costs about 4,000 US, right? And we use dual frequency receivers. But we can try and supplement that by having cheaper single frequency receivers to supplement the network. So we can do things like that to reduce costs, use less sensitive and more sensitive instruments to monitor GPS. So those are things that we do currently to manage costs. To answer your other question about the part of the electromagnetic spectrum, so in terms of the optical imagery, I think that's the visible part of the spectrum that was used. So that was limited by cloud cover, of course. But to monitor the ash plumes, they would have the satellites. I believe that they use infrared to monitor the trajectory of the ash clouds and to measure the content of the plumes in terms of SO2, for example. But that is also not my specific forte. I was collaborating with the agencies, but that's my basic understanding of it.
Okay, thank you. Taking off the first part of your response, there are quite inexpensive, but I presume also very imprecise devices that can pick up GPS information. Cell phones do it and stuff like that. Is there any value to a saturation of these low sensitivity devices? Can they give you some useful information in the event that you can't afford to have the right number of the more sensitive instruments?
I think Mikhail didn't explain what she meant when she said we are using GPS.
Yeah. So
in our work. So Mikhail, please
I'll explain it now. So
the precision and how exactly it works, so people can understand what we mean by GPS.
So essentially when volcanoes erupt or don't erupt, you can see changes in the volcano edifice. It might swell or deflate, but we can't see this with our human eye, right? We use sensitive instruments called GPS receivers that can detect millimeter scale movements. So that's the kind of precision that we're looking at that can be detected by the more expensive instruments that I was talking about. The less expensive instruments don't give you that level of precision. It can just give you more of a macro scale. Yeah.
I'm with you. Tell me, when you say GPS, are you being generic or are you specifically referring to GPS, given that there are other similar satellite systems about?
No, I'm speaking about, yes, GPS. So we have a network. We have a network of GPS receivers that actually receive satellite signals from satellites that are in space.
Yeah.
Right. So those are receiving those signals and trying to work out the exact location of a point on the ground, which is measured.
No, I understand that, but I'm saying like the Europeans have a separate satellite
right. So we use
location
all.
system.
We
We use all of them.
Galileo, all of them.
Okay.
Yeah. So
Okay.
so GNSS, that's the proper term.
Yeah, just to clarify it.
Oh, sorry.
So the GPS on your phone, or even the handled GPS, which is a device dedicated to find the location, has an accuracy of 2 to 10 meters, and we want to go down to less than a millimeter of movement, and especially in the vertical direction. That is the most important feature we're trying to do when we're trying. It is not the X and the Y, it is the vertical. We need to know if there is any difference in that direction. So when we are saying GPS, it is a specialized device. Yes, it is using the satellite to find the location, but the precision of the device is nothing compared to the civilian, let's put it that way, GPS, either a handheld or your phone GPS. The precision is like 1,000 times bigger. So we can say, okay, we are going to get access, let's say, to all Vincentian's phones, and from there we will figure out what's going on the volcano. That wouldn't work. We are talking about a totally different level of technology and precision.
Okay, thank you very much for clarifying that. Yeah, I am. Why I ask these questions, of course, is that I'm very sensitive to the cost issue, and the fact that La Soufrière is not the only volcano in our relatively poor region. So I'm interested in what sorts of potential solutions might exist that address our situation. But thank you very much.
If you have more money, that's the only solution we can find. Funds, so we can be able to do more work. I think Miss K must have got tired by waving her hand all this time. Please go ahead.
Fred, what was your question? Still on satellites?
Sorry, my question. My question was actually on where are we in compared to the rest of the world in terms of prediction and monitoring? And I have heard you, both of you, the experts, mention the challenges that we have with funding, I suppose, the ability to actually buy the sort of equipment that we need to improve monitoring. So just kind of curious as to where are we compared to, I don't know, the rest of the world. Are we modeling? Is there a benchmark that we are looking at? Is it the Americans? Is it what is the benchmark? And secondly, I kind of wanted to understand whether or not St. Vincent actually provided any new learnings for prediction and monitoring that could inform current approaches. That I'm sure there's a sort of global community that share knowledge as it arises from these sorts of events.
A few months, probably 6 months ago, I happened to attend a series of, it was a forum essentially of other people who are dealing with volcanoes. So we are not the worst, but definitely we are not the best. Because exclusively the volcanic monitoring happens by government agencies or universities, you are always at the point where you are begging or running behind someone to convince them to give you some money. And I have to tell you that it is an expensive sport. It is not cheap. The instruments are not cheap. The people who work are not cheap, because you need to educate them. So you need to have someone who went through 1 degree, 2nd degree, 3rd degree, 4th degree, and then you have to pay him adequately. So it is not cheap and it is not easy. So for example, at that certain forum. There were people from Chile, there were people from Colombia, there were people from Japan. Even Japan, that is probably one of the most advanced countries, they were complaining that, you know what, we want to do something and we can't because we have a lack of funds. Even the Americans, there is no ideal situation where you're like, okay, now we are at our top and we're fine, we are content. There's no such thing. There's always a need of let's do more. But I would say that to the basic level where you feel confident that if something happens, I will be able to respond and I won't be caught by surprise, like, let's say Dominica exploded and we're like, what? We didn't see anything about it. I think we are better than that. We could have been better, but again, funding is a problem. It's not the only problem, but it is a serious problem. Funding, the topography, like how they are spread around. I would dare to say, being non-Caribbean, the Caribbean culture, all of them, they are obstacles. I think that, I hope at least that given how well the La Soufrière was managed, and especially with that, the fact that we didn't have any fatalities, we gave a good example to all the countries in the West Indies that, and the good thing was that the government actually worked with us. So when we said, you know what, we need immediately A, B, C, D, they were like, okay, go get it. We are behind you. So I hope that we show to the rest of the Caribbean islands that if they work with us, we have the capacity and the capability to do a good work and help the islands go through the ongoing crisis. But there's still a lot of steps to be done, to be like, okay, no more stress, everything is working fine, the sun outside is shining, we can all calm down. There is always something that is stressing us out in one island or the other.
Thank you.
All right, Kamala K, your hand is up. Do you have a question?
Yeah, and I was kind of moving away from the monitoring, so which is, you know, why I asked Fred to go first if he was continuing on that vein. But it's a couple of things. Well, quickly, first of all, do you have to pay for satellite a subscription to a satellite service, for instance? Because I know for certain specific and specialized use of GPS out here where we need very, very precise measurements, a subscription to a satellite service is required. So, Mikhail?
Not for GPS monitoring. We don't need to pay. We just, the receivers that we have just take the satellite signals that are orbiting all the time. But if you want to have high resolution imagery taken of specific locations, some of them are not free. Some of them are free, not many, but some are free, but most of them are not. And the satellites also don't pass very often. So for example, before the eruption started, one satellite radar used to pass over the Caribbean once a year. Another one used to pass over every 12 to 14 days. And then when we had the explosions, we actually made requests to these agencies if they could increase the acquisition of the satellite radar to help us with the monitoring. But we also had to be considerate to the other islands. We didn't want to have all the resources concentrated in St. Vincent while Martinique was in unrest. We had to be considerate to make sure that they continued their acquisitions over those islands as well. So it's all about collaboration, but they acquiesced our request and they increased the acquisitions in one case to every 6 days, another case to every 14 days. So those can change, but not all of those are free. So, if we decide to incorporate satellite monitoring more heavily into our routine monitoring, we have to consider those additional payments, but there are free ones that do the job just as well.
Cool. And before Davisha take back the mic and before we wrap up, I had two other questions that were maybe a little not on the monitoring question. One was, there's a slide that Dr. Papadopoulos showed with how much ash was deposited. And as a geotechnical engineer, I am concerned with deposits on land and how we build on top of them. So I just wanted to know how much, what was the highest level of ash that was deposited in any one area in this event?
I don't have those figures on me. I think
don't
they're
think
currently.
we have a number as a number, but the picture that okay, so we have two different ways of deposits. The one is what fell from the sky, so it is the ash that gently deposited on the ground and covered the whole island, same as in Barbados. I don't think that this exceeded maybe half a foot, at least to the parts that we were able to access. I don't know what's going on. Obviously, inside the crater, it might be like dozens or even hundreds of meters. But the tephra that's covering there. But what fell on the island as from the sky, it was, at least from what I saw when I walked around to the western side and to the northern side, I would say that it never exceeded more than half a foot. There is a second level of deposition, though, which is what happens when you have the pyroclastic flows and lahars. So through valleys and riverbanks and whatnot, due to gravity, you will have either pyroclastic flows, which is debris, gas, ash, rocks, boulders, anything that you can think of that is on the flank, and then it comes down. Which is being deposited, and that's the picture that I showed you when I said there's two little people sitting on top of there, okay? So inside the Larakai River, I think that it is at least 20 to 30 meters of deposit. And these have been deposited one on top of the other, and you can actually see, I mean, if you are there, you can actually see the distinguished layers. You see, it's like a cake. You see one layer, and then you see a line that defines the second layer. This does not really affect the building because no one's going to build inside the riverbank. So building-wise, and that was one of the roles why I was there as an engineering seismologist, was to see if this is going to affect the building stock, either the present or the future. The ash is not really a problem when it comes to buildings, either current or future.
It will be in 1,000 years.
No, because this is so loose, it is ash, it is like sand. It is so loose that it will be washed away, and whatever will remain, it will become loose soil, but this is the case that you have anywhere in the world. It is the top, I don't know, 5 inches of soil that you see everywhere on Earth. So it is not an issue that is going to change the stability of the buildings, either present or future.
I have to disagree with that as a geotechnical engineer, because we have volcanic deposits in Jamaica and they are headachy, and they are not thin, they are very thick
the volcanic
and very landslide susceptible, and people build on them, and it's a huge problem.
The volcanic deposits that you have in Jamaica are a product of millions of years ago, and they are, as they are, to erosion. It is not the same material that we have right now in St. Vincent. That's what I'm trying to say. Obviously, the volcanic deposits do not give you stable ground to build. But and this is the case in St. Vincent too. If you go to the first 10 or 15 meters, which is from eruptions that happened millions or billions of years ago, you have the same problem. But this ash that fell, this is not going to affect like the geotechnical community.
No, what I'm saying is that what we're seeing is history in real time.
When it comes to the deposits that came out from the valleys, yes, because this is not going to go away. So when we're talking about deposits that came down from lahars and PDCs, this is what you have in Jamaica. You have something that came down and stayed there. Whatever fell from the sky is going to be washed away.
Hopefully that is a satisfactory answer for now. Are you okay with that?
Somewhat.
Okay, well, maybe we can have a follow-up event where you two debates the future effects. No? Okay. Anyway, there's one last comment that I think would be a nice note to end on is, I know it's still early, but have either of you noticed an increase in interest in geography, geology, and volcano studies so far?
You mean from young people who
Since,
might know it?
yes, since the recent events in St. Vincent.
We are not part of the educational process, so we don't really have eyes on that. We don't teach, we are just researchers. But I noticed, and I think Mikhail probably can verify that while this was ongoing and everybody's attention was on us and whatnot, on the social media, there was a lot of people who were saying, oh, I always wanted to become a geographer or a volcanologist, or I want to become. So obviously events like that potentially will affect someone's decision of the future. Like, you know what? Elias looks cool. I want to be like Elias. It is a possibility, like, or she does something cool, so it looks interesting. Of course, they don't understand what is behind it. They see just, you know, the front part. I would expect, though, that yes, people from the region and most likely from, hold on, because I have the cat. Come here. From the region and most likely from St. Vincent might see it with more interest. Like, okay, this is something that it can happen on my island, and I would like to have a saying in that, or I would like to know more.
Yeah, just to follow on from that, Elias, this will be a good way to build up that local capacity. So when I was in St. Vincent earlier this year, there was a big move to involve the local geoscientists to help us with the monitoring. When I did some field work, I did invite some locals to help me with the field work. And I think the plan is to hire some local people to continue the monitoring, because of course we have other volcanoes to monitor. So it's imperative that St. Vincent utilize the resources that they have. And I'm sure they have a lot of people who are capable of doing the work that we do currently. So it'll be interesting to see how this eruption develops their own local talent going forward.
Yeah, as a closing remark, and since I suspect that all the participants are from different islands, yes, there are geoscientists in St. Vincent, and they did come and find us, and they said, you know what, I studied geology, I studied geotechnical. The problem is not the people. It is not that the islands, same in Dominica, because right before going to St. Vincent, I was in Dominica. It is not that the islands are lacking people, professionals. It is that the agencies, or if you want, the government, they haven't invested in the local stock of professionals to train them and say, you know what, we will build a small team, we will still have UE because we can afford to have our own network, or it doesn't even make much sense because it's such a small island to monitor earthquakes. But we will let UE take the lead, do the whole thing, but we will have a local team of 2 or 3 people who will be adequately trained and who will do the work here, rather than they have to call us every time and say, okay, who's flying now to St. Vincent to do the job? The St. Vincent government promised, at least to us, verbally, that they plan to have 2 or 3 people permanently hired, that they are going to be assigned to the Belmont Observatory and build local capacity in terms of seismic monitoring, in terms of GPS, in terms of mapping deposits and whatnot. We hope that it will be true.
That's definitely a good goal for each island, and it would certainly be cost effective and save you all a lot of time. Well, that is our time, even with the extension. Thank you so much to Mikhail and Elias for answering so many questions and so well. Thank you to the audience for your engagement for the last hour and a half. And thank you to our hosts at CARISTEM for this opportunity. I hope everyone enjoyed their evening, and I guess stay tuned for the next event. Thank you.
Pleasure.
Thank you very
Thank
much.
you. Thank you,
Thank you very
everyone.
much.
Thank you.
Thank you,
It was a
guys.
real pleasure. Bye-bye. Have a great evening.
Can I just ask
All
that?
right,
Do
good
we
night.
have Mikhail's and Elias's contact details, and of course
I-
yours, teacher? Yeah.
I do, and the Vishas.
Good.
We have all three.
Good. All right. We'll definitely be in touch and get a plug in when you're hosting events as well. Thank you.
Good night.
Right.
Okay.
Good night, everyone.
Bye.
Cheers.